Now we need to start detailing the slab. It is important to check the option Impose Minimum Reinforcement from the Flexure Design. Show all the layers and both the top and bottom rebar just in order to get an idea which number of the bars will be selected. If you are selecting a mesh, go for typical bar as we used to do in the previous videos. But right now I will not be going for the mesh option. So we will be starting the flexure design all over again. Go to display flexure and uncheck this option. In case of waffle slab, let's select the top bar of number 6 and bottom as well as of 6. So you see the number of bars written on the blue lines. The blue line basically shows the reinforcement. Now for layer A, top reinforcement. The blue color is the bar and the black line shows the distribution of the bar in that direction. So these bars will be placed in the drop panel. For that we need to calculate the spacing of the bars, that whether they are not too close. The drop panel dimension is 11 multiplied by 12 will give us 132 inches of drop panel dimension, and divided in 48 bars leaves us with spacing of 2.75 inches, which is too low. So we need to increase the diameter of the bar, let's say number 8. So now we are getting a lower number of bars. Let's select the highest number of bars for layer A, top layer, inside the drop panels. The drop panel dimension is 11 into 12. The bars are 31. So the spacing will be 4 inches. That is fair enough. Now we need to go to AutoCAD. Since we are working on layer A, for layer A the section here is cut as the blue color shows the reinforcing bar, and the black line when we hover the cursor over the bar shows the distribution. So the section B is cut horizontally. The section BB shows layer A reinforcement. For drop panel we just found out the bars. Number 8 at 4 inches center to center. Since it's for drop panel, let's name it as drop top. For the top bars apart from the drop panel, we are getting very low number of bars. So the spacing would be exceeding 18 inches limit. So let's calculate the spacing. 198 inches divided by 33. So we need to decrease the diameter of the bar so that we get a lower spacing and more number of bars. Let's calculate the spacing again. Let's take the spacing as 18 inches. You can decrease or round down the spacings, but you should not increase the spacing that is coming out from the design. Number 6, at 18 inches center to center. By design it was 19 point something inch, but we round it down to 18 inch, which is fair enough. Now for the bottom reinforcement in the drop panels, the highest number I am getting here is 24, number 6. For that we need to check the spacing. .198 is the strip width. The 8 inches spacing comes out in the waffle direction. For timing, I just place it in terms of spacing. When I am done with layer B, I will tell you how to place bars in the waffles actually. Let's skip that part right now. So the strip width of the column in the corner divided by the number of bars gives us 8 inch center to center spacing. Number 6, at 8 inch center to center bottom. In the same way, we need to detail the section AA. Or the layer B. So the top bars in layer B are shown. If you didn't understand the placement of reinforcement in layer A, you can understand it in layer B. The section A is cut vertically basically in the plan. So we are looking at the bars of the layer B. Let's start with the detailing of the top bars in layer B. Starting with the drop panel top bars. The number which we are getting is a high number. So we need to increase the diameter of the bar to decrease the number of the bars and check the spacing. So let's pick the highest number in the drop panel top bars as 32, number 8. Let's check the spacing. The drop panel dimension is 11 multiplied by 12. That gives us 132 inches. 132 inches is divided for 32 bars. The spacing comes out to be 4 inches between the bars. That is fair enough. So the top bars of the drop panel in layer B is number 8 at 4 inches center to center. Drop top. For the slab part apart from the drop panel, Let's decrease the number or diameter of the bars to number 6. So we are getting 11 bars away from the drop panel. Let's make it 198 inches is the strip width divided by the number of bars gives us 18 inches. That is fair enough. The spacing shall not be typically greater than 18 inches and less than 4 inches would be difficult to place on site. So for the bottom part of the drop panel, go to display Flexure Design again and check the bottom bar option and uncheck the top bar. So now you see we are getting a high number, that is 26. Number 6 is the highest number. Let's check whether it is placeable or not by calculating spacing. 198 is the strip width divided by 26 bars gives us spacing of 7 inches. Let's say number 6 at 7 inches center to center. Now the last part is how to place bars in the waffles, which I skipped previously. So the number of waffles must be calculated. The 33 feet is the span minus the drop panels 5.5 feet from both dimensions, or simply subtract 11. So the drop panels number is 33 feet minus 11. That leaves us the clear span for drop panel divided by 2. Is the number of waffles. Since the center to center spacing between the waffles is 2, so there are 11 waffles or ribs between the drop panels. So we need to select the multiple of 11, the bars. Since the drop panel width is 6 inches, so 2 bars can be placed in each waffle. The maximum allowable bars are 24 in each span because there are 11 waffles, which we already calculated. So we are getting 19 number 7 bars. Let's place number 7 bars, 2 number 7 bars in each waffle, and there are 11 waffles. That makes 24 number 7 bars, which is fair enough. The number of bars shall not be less than the coming out from design. You may increase number of bars in order to round up to the waffle numbers. Similarly for the other layer, the number of waffles is same, that was 33 feet minus the drop panel dimension 11 feet, that leaves us 22 feet clear span for waffles. Divide with the center to center spacing between the waffles gives us 11 waffles, and 2 bars are placed in each waffle. That is, a maximum of 24 bars can be placed within the waffles. So selecting the bar, 24 number 6 is the highest number we are getting. That is fair enough. Remove the spacing option since it's a beam or ribs. Place in number of bars terms. Typical bottom. in each waffle or rib. Now for the nodes part, we need to enter the thickness of the slab which we selected. 5-inch thick. We need to provide the camber. How to calculate the camber? You need to go to display deflected shape, displacement in x direct, y direct, z direction, and the maximum deflection is 3.87 and the allowable was 1.65. So we need to provide a camber of 2.22 inches. The ribs were 12 inches deep and the width of the rib was 6 inches. The cylindrical strength of concrete was 5 kSI. The yield strength of steel is 60 kSI. The drop panel thickness was equal to the ribs dimension that was revised to 12 inches. The drop panel thickness is also 12 inches. The dimension of the drop panels were 11 feet or 5.5 feet in each span from each side. Thank you for watching. Click on link